Welcome back, students, to section 911, double integrals in polar coordinates. So it's the same as 910, but sometimes questions in 910 cannot be integrated. So we have to move to something called polar coordinates. So what's a polar coordinate? Let's imagine, guys, you have this point here, which is the point X and Y, somewhere in the XY plane. How do you reach to this point? What do? You move on the x-axis, x distance, and then you move all the way up, y distance, and this will take you to the point x and y, correct? This is how we reach it. So to reach to this point x and y, you move in the x-axis, x distance, then up on the y-axis, y distance, and this will bring you to the point x and y in the xy plane. So this is our x-axis, and this is the y-axis. Now we can reach to this point in another way. What's the other way? Imagine, guys, there is a circle here that is passing through this point. Here's a circle that is passing through this point. Now, we know that according to the Pythagorean theorem, that if I take this arrow here, this will represent what? Definitely the radius of the circle, isn't it? So I'm going to call it R. So let R be the radius of the circle that starts from the origin all the way to the point X and Y. Perfect. Now, according to Pythagorean theorem, then the radius of this one is x squared plus y squared, correct? So we have R squared is equal to x squared plus y squared, which is something we all know. Also from Pythagorean theorem, what do we know? We know that sine theta is the opposite over hypotenuse. Who's the opposite to theta? This is the angle theta. The opposite is y, definitely. And the hypotenuse now is what? Is r. So I'm going to put a 1 here and do cross product between this and that. So we know that y times 1. So y is equal to r sine theta. So also we know that cosine theta is the adjacent divided by the hypotenuse. What's the adjacent to theta now? This is theta. The adjacent is this one, which is x over the hypotenuse, which is r. We do the same thing. X times 1 is x equal to r cosine theta. So what am I doing now? I'm trying to convert the point x and y to something new. So this order pair, by the way, x and y, will be nothing but x, we said, is r cosine theta, and y will be r sine theta. And so what am I doing? I am parameterizing the point, remember, into this r cosine theta and r sine theta. This is how you change it. And we know that r here is equal to x squared plus y squared. What does that mean, guys, in polar coordinates? How am I going to reach to this point x and y using polar presentation? So look at the point. Here's the point now. I'm going to make another graph. Here is the point x and y. Let's take this line that goes all the way to x line and call this one r. Now, imagine the circle that has this. So this is also what now? This is also r. So what's going to happen now? This radius r, to reach to the point xy, I need to measure what r is. So if I took this arrow of length r and I move it with an angle what? Theta, this will bring me to here. So what am I touching now? I'm touching the point x and y. So how can I reach to the point x and y? Very simple. Measure the distance between x and y and the origin, which is r, which is equal x squared plus y squared. Find it. And then find the angle that takes you, that is the distance between r and the x plane, x axis, sorry. What's the angle between the x axis and that r? We know this is theta. Find theta and take this r from the x axis all the way to the with theta equals something, I don't know what's that, and then this will take you to the point X and Y. And this is, guys, how we convert the point X and Y into polar coordinates. So X and Y is called the Cartesian coordinate, and we can convert it to the polar coordinate by finding two things, R and theta. How do I find R? This one. How do we find theta? You can use these identities to find theta. I will show you in the examples. Okay, so now let's start our work and show you now how do we convert our work on 910 to 911. So what happens in 910? Remember 910, you have a solid, you need to find the volume of the solid. How do you find it? Inside the integral, what do we put? This is the formula. We put f of xy, which is actually z. And then what do we say? dA, the area of what? Of the base, the region, right? Remember, the region means the base of the solid is going to stand on the xy plane. And this region could be of type 1 and type 2. And this is what we did in 910. Go back to 910, guys, and see what we did in 910. What's the problem now? The problem is sometimes this one, when you do dy dx or dx dy, you will notice that no matter how you switch, remember in the 9.10, we said if we can't integrate, we switch, then we can integrate. What if you switched and you couldn't integrate? So means what now? You're going to face the problem that this is not integrable. Sorry. So we're going to face the fact that this is not integrable. Even if you reverse the order of integration, you find still it can't be integrable. So one way to overcome this issue is to convert our work from rectangular xy plane, the Cartesian xy plane, to the polar presentation of the function. So what's going to happen? When do we apply this? And you cannot do this, by the way. You can't use the polar coordinates unless if this happens. What's going to happen? Look at this. You base the region, this R, which could be type 1 or type 2. It has to have a region that is bounded between two rays or any straight line that go from the origin. See, it's bounded. Look at this region. This is our region. It's bounded between this ray, okay, and this ray. Got it? If I have a region that is bounded between two rays, perfect. Also, the two rays go to infinity, as you see, right? But to have a region, it has to have a lower bound. This is the first thread is our lower bound. This one is going to be a function of theta. So we call it R1. And this R is a function of any other theta. So this is going to be a function of theta, and this is going to be a function of theta. So what's going to happen? Our region is bounded between two rays, and from the top and the bottom between what? Two functions of theta. If I have something like that, then we can use polar coordinates. So mainly, guys, your region has to be mainly bounded between two rays and these two functions. But these two functions we can deal with. The major thing is it is bounded between two rays. And in this case, what do? We know the volume from the previous section is this, and could be, this one could be region 1 or type 1 or type 2. We don't care now. We can't integrate. So what do? We are going to convert everything to polar coordinates. How? We're going to change dA, which is dx dy or dy dx, into r dr d theta. Okay. What is theta? Theta, look at this, starts from the distance or the angle between the x-axis and the first ray, which is what? Alpha. So you see alpha here. Now, to continue the region, you have to move now what? To this ray. This ray has an angle equal to what? Beta between this ray and the x-axis. So theta is going to be from alpha to beta. So the change in theta, which is how far is the first ray from the x-axis, then how far is the second ray from the x-axis. And those go where? On the limits of integration of theta. How about R? R, by the way, is the length of that ray. The ray starts from here and goes all the way to what? To here. Who's this at the bottom? It's G1. Who's this on the top? It's G2. Done. And this is how you find the volume of the solid using. And then, of course, inside, any X will be R cosine theta. So this is, we know that R cosine theta, and Y will be replaced with what? R sine theta. So this will make everything in terms of what? R and theta. And you're done. Again, you will change X to R cosine theta and Y equal to R sine theta inside the integration. And on the boundaries here, instead of having type 1 or type 2, you're going to change it to what? R d theta. What's theta? It's the angle between the x-axis and the first row, and then the angle between the x-axis and the second row, and the second arrow, sorry, and this will be alpha and beta. What's R? It's the magnitude of this arrow. Starts from here, ends there, and this would be from G1 to G2, and those are the limits that go in terms of R. And then you finish the integration, you find yourself easily integrating the function. All right, let's do this example, guys. Use polar coordinates to show that the volume of the sphere is 4 over 3 pi a cubed. Remember, this is something we know. The volume of the sphere is 4/3 pi r a cubed. Okay, let's find it. Now, what do we know about the equation of the sphere? Okay, of radius a. We have x squared plus y squared plus z squared equal a squared. We know that this is a sphere of radius a, isn't it? So let's graph this one. Let's suppose this is a on the y-axis, and this is negative a on the y-axis. This is now z-axis. Now this is a on the z-axis, and if we go down, this is negative a on the z-axis. 1, 2, 3. Here is, for example, let's say a on the x-axis, and this is negative a on the x-axis. And we graphed the sphere before, if you remember. So let's use the red one here. And then you go like that. And then it goes down. And then on the x-axis, you can go like this. And in the back, we go like that. So here is a sphere of radius a. It's again on the x-axis, it's a and minus a. On the y-axis, it's a and minus a. On the z-axis, it's a and negative a. Perfect. I need to find the volume of this sphere. What do we do, guys? To do this one, I would say the volume is equal to the integration, double integration of f of xy dA over r, isn't it? This is in 9.10. Now, inside, what do you put inside? We put the z, right? Fxy is z. So let's go back here, guys, and look at z. What's this here? From this one, we know that if I solve for z, z squared is what? A squared minus x squared minus what? Y squared. So if I take the square root of that, so z is going to be plus minus square root of a squared minus x squared minus y squared. Now, which one is the positive part? This one is the z equal to the positive a squared minus x squared minus y squared. And the one here, the bottom one is z equal square root with negative a squared minus x squared minus y squared. So what I'm going to do now, I'm going to take the volume of only the upper one. Let's focus on the upper sphere only and ignore the lower one. Let's take only the upper one, guys. This is our sphere now, the top one. We don't care about the bottom one. And I'm going to multiply the whole thing by what? By 2. So I'm going to find the volume of the only top one. And then the bottom is symmetric, right? The bottom is the same thing. And I'm going to multiply by 2. Why is that? Because remember, in 9.10, we said every solid must have a base on what? On the XY plane. So look at this solid, that the blue one, guys. What's the base on the XY plane? This is the Y-axis and this is the X-axis. If you look carefully at your base, what is this? This is, by the way, a circle of radius A, isn't it? So I'm going to graph it here. Here is the X-axis and here is the Y-axis. This is our base. It's a circle of radius A, negative A, and negative A. This is our base on the XY plane. All right. Here, remember, I'm going to just take what? The upper part. What's the upper part? This is the upper part. So Z is equal to square root of A square minus X square minus Y square. And then what do we say, guys? dA over what? Over R. Wonderful. Now, what I'm going to do now, this is never integrable. No matter what you do, you cannot integrate this one easily. This is not integrable. So even if you took dy dx or dx dy, you cannot integrate that one easily. So what do? We will convert everything to polar. Now again, don't forget the 2. Why is 2 here? Because this is the volume of upper sphere only. So I multiply it to get it the whole sphere. Alrighty, now we know this can be written as A square. I'm going to factor out the minus. So what do we get? We get X squared plus Y squared. Then dA over R. All right. So what do we know in polar? What's X squared plus Y squared if I want to change it? We know in polar, if you go back here, we said that X squared plus Y squared is equal to what? R squared. So what I'm going to do, I will change this one to R squared. So this is equal to 2 double integration of square root of A squared minus R squared now. And when you change this in polar, what do you write? You write R, dr, and d theta. Correct? This is how you change to polar. Now, let's look at our boundaries. The base is a circle of radius r. So what I'm going to do now, I will define my region. My region is the whole circle. Okay, the whole circle is like this. Let's take an arrow. This is what? This is R. Okay, our arrow is R. Now, what's the length of this one? Starts from where, guys? Starts from 0, ends at where? Isn't it this A? So the length of this R is from 0 to A, right? It starts from the origin, goes all the way to A. So this is the length of it. Remember, the top minus the bottom. Let me show you what I mean in the graph that I showed you here. This one is the bottom one, and this one is the top one. So it starts from, but in my graph, it starts from the origin all the way to the A. So here it is. So it starts from here, and now it starts rotate. So this is our curve, you see? This R is going to rotate to cover the whole circle. So this R will start moving, okay, all the way to cover the whole circle. How much do we have to rotate? We start our theta. We start from here, so in the x-axis, which is 0, up to full rotation to y. So if I took this R, you see this R of length from 0 to A, which is length A from 0 to A, and I rotate it 360 degrees, this will cover the whole base, isn't it? And this is, guys, how you convert everything into polar. Now, how do we integrate? This is the question. To integrate this one, by the way, let u equal a square minus r squared. Everything inside, call it u. Remember, what do we do first, by the way? You have to be careful here. I have to also specify what I'm going to do. First, we start our integration from the inside. Who's in the inside with respect to r? So how do you do this one? Okay, to integrate with respect to r, let the inside the square root, call it u. So du over dr is minus 2r. Bring this one here. So du is equal to minus 2r dr. What do we have? We have r dr. So I'm going to divide by 2. So du over 2 is minus, I'm going to actually divide by negative 2, is r dr. So this is equal to 2 integration from 0 to 2 pi. Open the box again. I call this u, right? So actually I can do it here. So what's the integration of the square root of a squared minus r squared times r dr? Let's see, what do we get from this one, guys? So again, I'm going to integrate the inside without from 0 to a, just the integral itself. This is the integration of square root of u. What's r dr equal to? It's du over negative 2. Take the minus half outside. I'm left with the integration of square root of u, which is u to the half du. What's the integration of u to the half? It's u to the 3 over 2 times 2 over 3. This 2 goes with this one. What am I left with? 1 over 3 u to the 3 half. But what's u? U is a square minus r square. And probably we forgot the negative. There should be a negative here. Here is a negative, and the answer is here negative. And this is to the 3 half. So this is the final answer for the integration. So this is equal to minus 1 half a square minus r square to the 3 half. All is from 0 to a. And we say what? D theta. I hope I left space. Unfortunately, I did not. All right. Now, what do? We say this is equal to, now, this 2, by the way, goes with this 2, and the minus goes outside. So this is negative. You have minus integration from 0 to 2 pi. Now, look what I'm going to do. I will plot the a first. If I put a here, what do we get? We get what? 0. So you get 0 minus. By the way, don't forget the minus went out with the half. Put the 0 here for r square. You get a square. So you get a square to the 3 half d theta. Now this goes with that. What am I left with? Minus a cube. And there is a minus outside. Take it out. So it's going to be a cube outside. Then the integration from 0 to 2 pi of d theta. Now, what did we miss in our work? We said this one is the integration of that. We said 2, actually it's 3. It's not 2, this is a 3. So this does not cancel actually. This is 3. So it's going to be 2/3 of all of that. So here we have 2/3. Again, sorry, this is minus 1/3, so it's minus 1/3 this. So this is minus 1/3 over here. Minus 1/3 times 2 is minus 2/3. So the answer is negative 2/3. Let's not cancel that. Let's not cancel this. Let's not, let me show you the way again. So the mistake was actually here. Okay. So this is minus 1/3, and there was a 2 outside. So what I did now, this minus 1/3 is going to go with this one. So you have minus 2/3 out. So, and this is equal to minus 2/3. Then remember, when you put the 0, when you put the a, you get 0. When you put the 0, you get a squared, and this is going to be a cubed. A squared to the 3/2 is a cubed. Now, what's the integration of that? What's the integration of d theta? It's equal to theta, isn't it? So what I'm going to do, I will take this one here, a little bit up. So this one is equal to minus 2/3 a cube. The integration of d theta, we know it's a theta from 0 to what? To 2 pi. It's theta from 0 to 2 pi. And this is equal to minus 2/3. And by the way, when we put this minus, we forget that this minus with this minus will be plus. So this is plus. Again, when we put the a, we get 0. Here is 0 minus, put the 0, there is a minus outside, so it's going to be minus a cube. Now, minus with minus, these two minuses, they cancel, and you're left with 2/3 a cube. So I have 2/3 a cube, the integration from this one to this one. Now put 2 pi, so this is 2 out of 3 a cube. Then put 2 pi minus 0, the top minus the bottom, which is equal to 2 pi. 2 pi times 2 is 4/3 pi a cube. And this is exactly the volume of the sphere. Okay, so this is how you find the volume of the sphere. Let's do that one. This one, as you see, dx dy. Can you integrate this one? Impossible. With dy, you can't, because you need the derivative of y squared, which is 2y, which is not on the top. So this cannot be integrated. So what do we do in this case? We convert everything to polar. How do we do this? Very simple. Before I start this one, let's see, do we have a polar region? Polar region usually has 2 rays, and it's like circular thing. So what do we do? Let's look at x. X is from where to where, guys? From 0 to 2. So we know that x is from 0 up to x equal what? 2. For the y, it's from x to y equal square root of 8 minus x squared. So let's graph this to see if we can graph that region. So what I'm going to graph now, by the way, is the region only. In the xy plane. I'm going to graph my region. X is from 0 to 2. Here is x0, which is this one, of course, x equal to 0. To x equal 2, here is 2. So this is x equal to 2, guys. This line is x equal to 2. And this is the x-axis, and that is the y-axis. Now, let's go to y. What's for y? Y equal to x. You know, this is y equal to x. We all know the graph of y equal to x. And then y equal to square root of 8 minus x squared. What is this? If you take y equal 8 minus x squared, that, okay, square both sides. So this implies that y squared equal to 8 minus x squared. Move minus x squared to the other side. So what do we have? We have x squared plus y squared equal to what? 8. This is a circle of radius what? Root 8, right? This is a circle of radius root 8. Okay, r here is root 8, which is actually 2 root 2. So 2 root 2 is more than 2, so it's going to be somewhere here, okay? And it will make that circle of radius root 8. All right? What's the intersection between those two? This one, by the way, y equal x. And this one, y equal which part of the circle? It's 8 minus x squared. So to find the intersection between them, I'm going to take it here. Y equal x and y equal 8 minus x squared, since the left is equal to the left. So that means x is equal to square root of 8 minus x squared. Square both sides. So x squared is 8 minus x squared. Move this one to the other side. So 2x squared is equal to 8. So x squared is equal to 4. So x is equal plus minus what? 2. Here is 2, guys. And this is on the x-axis. Here is negative 2. So this line crosses the circle at what? At x equal 2 and negative 2. So what's this point here, by the way? This point is 2 and 2. Now look what it says. It says x is from 0 to 2. Fine. And y is from y equal x. This is y equal x. And y equal to this circle. So where is my region? This is actually my region, isn't it? And this is a region of type 1. Again, x from 0. Here's x equal to 0. To x equal 2. This is x equal to 2. Then y equal x, here it is. And y equal to the circle, here it is. So this is actually my region. So I noticed that this is like a pie, isn't it? So it's a circular region. Then definitely I can change it to polar. The question is, to do that, is what do we say? We said this is equal to the double integration of 1 over 5 plus, we know that this is what? R square. So here is R square. Don't put 8. Okay, it's just R square. Then what? R dr d theta. All right, so what do we need now, guys? I need the radius of this one. So look at this R. R is going to be this line. So let's change the color. This is, by the way, our R. This is the radius of the circle, isn't it? What's the length from here? This goes from 0 to what? To the circle. What's the circle? This is root 8, isn't it? So the length of this one is from 0 to square root of 8. This is the length of R. The problem now is theta. Theta means what? What's this? Theta, remember, from alpha to beta, right? So I have to find alpha and beta. What's alpha and what's beta? Alpha is the angle between the x-axis and that R. Do you know how to find it? Look, how do we find it? At this point, guys, we know this is point x2 and y2, isn't it? This is the point. So we know here that x is equal what? 2. Okay. X, we know that x is equal r cosine theta. Remember that. X is equal r cosine theta. And x here is what? 2 at this point. R is the radius of the circle is root 8 cosine theta. Fine. So cosine theta is equal to 2 over square root of 8, by the way, which is 2 over 2 root 2. This 2 goes with this one. So that means we have cosine theta is equal to what? 1 over root 2. But we know that cosine is equal to 1 root 2 is what? At pi over 4. So the distance from here to here is pi over 4. So the first ray in my region is 45 degrees from the x-axis. So I'm going to say this is pi over 4. Now let's go to this one. This is the end of our region. That's easy to find, isn't it? That's very easy to find. You know, this is 90, isn't it? So this is up to pi over 2. That's it, guys. We just changed everything to polar. You see, no more x, no more y. Now what do? We proceed with the integral. So this is, now, we need to integrate this. What do we do usually? We box the inside. We integrate with respect to r, guys. Okay, let me do it here. What's the integration of 1 over 5 plus r squared, then r dr? Let's take the denominator, call it u. So 5 plus r squared is the denominator. So what's du over dr equal to, it's this is 0, so you have 2r. Bring dr here, so du is 2r dr. I have only r dr, so divide by 2. There you are. So what's this integral going to be? I call the denominator u, and r dr is du over 2. This 2, I can take it out. What do we know about this integral, guys? This is half ln u, isn't it? The integration of that is ln u. But what's u? U is 5 plus r squared. So ln 5 plus r squared. Bring the half up. So this is going to be ln 5 plus r squared under the square root because it's half. So now what we're going to do is the following. I will take this integral here and say this is equal to integration from pi over 4 to pi over 2. And I'm going to put the result of the inner part. What's the result of the integration? It's ln 5 plus r squared. And this is from 0 to root 8. Close this one. And then what do we say? We say d theta. Alrighty, so now this is equal to integration from pi over 4 to pi over 2. Look, guys, if I replace r with root 8, what's the square of root 8? It's 8. 8 plus 5 is 13. So this is ln 13 minus, now let's put the 0. It's ln, of course, not 13, square root of 13, minus ln square root of 5. And this is what? D theta. And this can be written integration from pi over 4 to pi over 2 ln square root of 13 over square root of 5 d theta. This constant can go out, so this is ln. I can put this one, by the way, all of them in one piece under one square root. Then the integration from pi over 4 to pi over 2 of d theta. What's the integration of d theta? It's theta. So this is ln square root of 15 over 5, then theta from pi over 4 to pi over 2. And this is equal to ln square root of 15 over 5, 13 over 5, sorry. Of what now? Put the pi over 2. So this is pi over 2 first, minus pi over 4. Pi 2 over 2 times minus pi over 4 is pi over 4. So the final answer is pi over 4 ln square root of 13 over 5. This is the volume of this, and this is the result of the integration. All right, let's look at this question. Use polar coordinates to evaluate this, guys, where R is the circle of radius 2. The base is a circle of radius 2. Let me graph it. A circle of radius 2. That's our base. So this is 2, 2. So what do we do, guys, here? We can say this is equal to the double integration of, to change it to polar, we know this can be written as what? R square plus 3. Then we write what? R dr d theta. All right, where is R? Here's R, guys. That's our R. What's the length of R? Starts from where? From 0 to 2, isn't it? So R is from 0 to 2. Okay, to cover the whole circle, how much do I have to rotate, guys? Full rotation, isn't it? Full rotation will cover the whole circle. So it's from 0 to 2 pi, and that's it. Now we integrate. How do we integrate, guys? We integrate from inside. So this is equal to the integration from 0 to 2 pi. Open the box. Now, integration from 0 to 2. Let's open the bracket. R times R square is R cube plus 3R, then dr, all of that d theta. Now we can easily integrate. So this is 0 to 2 pi. The integration of R cube is R to the 4 over 4 plus 3 R squared over 2. And this is from 0 to 2 d theta. Now this is the inside, guys. Put the 2 first. So this is 0 to 2 pi. Usually plug the 2. 2 to the 4 is 16 over 4 plus 3. Put the 2 here, 4 over 2. And then, of course, when you put the 0, that's it. It's gone. So, and this is d theta. And this is equal to the integration from 0 to 2 pi. 16 over 4 is 4. Plus this 2 goes with this one. You get 2, 2 and 3 is 6 d theta, which is the 10 goes out. The integration from 0 to 2 pi d theta. And this is equal to 10. The integration of d theta is theta from 0 to 2 pi. What do we plug first? We plug the 2 pi, then minus the 0. And the final answer is 20 pi. This is actually the volume of the solid whose height is this. This is the top. I don't know what it looks like, but the base is a circle of radius 2. Okay, now find the volume cut out of this sphere and this cylinder. Now let's grab the sphere first, guys. What we have is a sphere of radius 2. Here is 1, here is 2. In the back, -1, -2. On the top, 1 and 2. At the bottom, we're going to go -1 and -2. So now we can graph actually the sphere of radius 2. Here it is. And you can make that circle here. And this is, by the way, on the x-axis is -2, and this is 2. Now, it says, and what? And the cylinder. How come this is a cylinder? Let's take this one, guys. X squared plus y squared equal 2y. Bring 2y to the other side. So what do we get? We get x squared plus y squared minus 2y is equal to 0. Let me now complete the square here. Remember how do you complete the square? So you get x squared plus y squared minus 2y. We add and subtract what? This b over 2. 2 over 2 is 1. So we add 1 and subtract 1 equal to 0. Now, what is this all? This is a perfect square. So what do we get from here? We get x squared plus, this is y minus 1 all squared, by the way. You see this -1, I'm going to move it to the other side, becomes 1. What is this? This is a circle of radius 1, but where is it centered at? Well, here x minus 0, which is 0, and 1. Here is, by the way, the point. This is on the x-axis 0, on the y-axis 1, right? So what do I have here? I'm going to graph this circle in red. Here is our circle of radius 1, centered at 0, 1. But he says this is what? This is a cylinder. Why? Because you see here, Z is what? Is a free, isn't it? There is no Z. So this circle is going to go up and down. When it goes up, what's going to happen? this circle is going to this cylinder. When it goes up, can you imagine the shape that when it goes up here? So we have a cut. It's going to go up and what? And it's going to go down too. So this cylinder is going to go up and down and cut the what? Cut the sphere. So this is going to be the top of the shape. What is this? The top is who's in the surface on the top? That's the sphere, right? What's the equation of the sphere here? You look at this. The sphere says x squared plus y squared plus z squared equal to 4. So z squared is equal to 4 minus x squared minus what? Y squared. And so that means z is plus minus square root of 4 minus x squared minus what? Y squared, which can be written actually as a square root plus, okay, plus minus 4. I can factor out the minus, which is equal to plus minus square root of 4 in polar. We know this is what? R squared. So this is the positive part of it. 4 minus R squared. Remember, we don't care about the bottom one now. We care about the top one. So let's talk about the top surface. He wants to find the volume. Fine. So the volume is equal to the double integration. Who's the surface on the top? What am I facing on the top? Okay, it's 4 minus R squared. And we say R, dr, and what? D theta. Now, I have to multiply by 2. Why is that? Because I'm going to talk about only the upper sphere, okay, just the top one. Ignore the bottom one and multiply by 2. Why only the top one? Because I need to find what's the base of the sphere. Huh? Look at this face. Where is my region by there? So the region, be careful. The region is the red one only, not the whole thing, not the whole sphere. I need the top sphere only. And this is my base. I will take this base and graph it in the XY plane, guys. What does the graph look like? It's a circle centered at what? X0, Y1. Here is 1, and here is 2. It's centered here, and this is, by the way, your circle. This is how it looks like on the XY plane, by the way. See, here's the Y-axis. This is, as you know, 2. Right? So, and this is the point 0, 1. And this is our circle. This is the base of that shape. So we are focusing on the top one. So if you like, I can make it in green to see what I'm talking about here. Just the top one. So I'm talking about this shape. Just that shape. This top one. You see that one? This is when the cylinder goes all the way up. The top up part is going, the upper part is going to be the surface of the sphere, and the base is this one. I took the base, and here it is. Here's our base, guys. This is a circle of radius 1. But where is it centered at? At 0 and 1. All right, what do we do usually? We take array, huh? Array starts from where? From 0. Where does it end up always? At this one, isn't it? But what's this? Isn't this the base? This one, the cylinder, right? This is our base. So this one is actually, let me write it here. This one is x squared plus y squared equal to what? To y. This changes one to r theta. We know this is what? R squared. So you have r squared is equal to 2. We know in polar r is what? R sine theta. Divide by r, divide by r. This goes with that. So r is equal to what? 2 sine theta. So my r now, radius, is going to start from 0 and at what? 2 sine theta. So when it comes to r, guys, r is from 0 to 2 sine theta. That's the length of the radius of the r. But where should it start from? It's going to start from here on the x-axis, isn't it? And then it's going to continue all the way till we stop here. What is this? This is pi. So the first is 0 up to what? to pi. That's it. This is my question. This is how you set up the question, by the way. Now we need to integrate that one. How do you integrate this one? So we usually close inside here and we close inside here. So let me look at the integration, guys, of 4 minus r squared times r dr. Alrighty, so let u equal 4 minus r squared. So du is equal minus 2r dr. Divide, because you have only r dr, divide by minus 2. So du over negative 2 is r dr. So this is going to be what, guys? This is the integration of square root of u. Then du over negative 2. This negative 2 goes out. U, square root of u, what's this is u to the half. What's the integration of that? 3/2 times 2/3. All right. So this is what, this is not supposed to be a minus half. This is minus 1/2. So this goes with that. And the final answer is negative u to the 3/2 over 3. Which is equal to negative, u is what? 4 minus r squared. So 4 minus r squared to the 3/2 over 3. So this is equal, guys, to integration 0 to pi. The result of that is minus 4 minus r squared to the 3/2 over 3 from 0 to 2 sine theta, and you say d theta. I'm going to take this 3 and negative everything out. So this is equal to minus 2/3 integration from 0 to 2 pi, from 0 to pi of only 4 minus r squared to the 3/2 from 0 to 2 sine theta, and then d theta. And this is minus 2/3 integration from 0 to pi. Now let's put 2 sine theta here. What do we get? We get 4 minus 4 sine square theta to the power 3/2. Then what do we plug now? 0. 4 minus 0 is 4. So minus 4 to the 3/2. 4 is 2 squared. So this is going to be 8, by the way. And then d theta. Okay. Just 1 second. There's a lag here. All right, now we're back. Okay. Now, this is minus 8 here. Okay. Now this is multiplied by minus 2/3. So this is equal to negative 2/3 integration from 0 to pi. Now, I can take the 4 out, factor it. So what am I left with? 1 minus sine square theta, all to the 3/2 minus 8 d theta, which is equal to minus 2/3 integration from 0 to pi. Now 4 to the 3/2 is 8, isn't it? So this is 8, 1 minus sine square theta. By the way, let me change minus this one. Why am I keeping writing this one? 1 minus sine square is what? It's cosine square, isn't it? So this one is 8 cosine square theta. This to the what? To the 3/2 minus 8 d theta. All right, so far. Now, this 8 can be factored out. So this is going to be minus 16 over 3. And I'm left the integration from 0 to pi. You know, this square goes with this square. So you have cosine cube theta minus 1 d theta. So let me copy it there. Negative 16 over 3, integration from 0 to pi of cosine cube theta minus 1 d theta. Now, this is equal to minus 16 over 3. I'm going to distribute the integral 0 to pi of cosine cube theta d theta minus the integration of d theta from 0 to pi. And all of this is multiplied by negative 16 over 3. Now, let's go on the side here, guys, and see what's the integration of cosine cube. So this is by itself is another technique. Huh? What's the integration of cosine cube theta d theta? If you remember from calculus 2, if you have cosine to the power odd, what do? We factor out one cosine, and you're left with cosine square theta, then cosine theta d theta. Then what do we do with this one? We change it to 1 minus sine square. So this is 1 minus sine square theta, then cosine theta d theta. Then what do? Everything here is terms of sine. You see, I'm going to let, move this one down here. Here, we will let u equal sine theta. So du is cosine theta d theta. So what does this turn out to be? 1 minus, I call this one u, so this is u square. And cosine theta d theta is what? Is du. Now it's easy to integrate. The integration of 1 is u. The integration of u square is u cubed over 3. So the final answer, you know, u is sine, so the answer is sine theta minus sine cube theta over 3. So let's go back to my answer. So this is negative 16 over 3, open bracket. The integration of this one is sine theta minus sine cube theta over 3 minus the integration of this one, by the way, is theta, and this is from 0 to pi. What do we do now? This is negative 16 over 3. We start with plugging pi. If I put pi here, we get sine pi minus sine cube pi over 3 minus pi. Then we say minus, what do we plug the 0? Sine 0 minus becomes plus sine cube 0 over 3 minus, we put 0 plus 0, of course, and we close. Put pi first, minus the 0. Sine pi is 0, this is 0, this is 0, and this is 0. So what's left inside is negative pi. So the final answer is 16 pi over 3. This is the volume of this sphere, of this solid, guys. All right? Find the volume of the surface bounded by all of this. So to make it easy, we already understand that this is our Z, and we know this is what? The upper sphere of a sphere of radius 2 is radius 4, isn't it? So remember, this is upper sphere of radius 4. So let's graph it. Radius 4, and we fix my numberings, and this is not good. So let's put it in a different way. Okay, here it is. I'm gonna go here. Four, 1, 2, 3, and 4. 1, 2, 3, and 4, I will need only the upper part of the sphere, guys. 1, 2, 3, and 4. That's good. And from here, you can go, by the way, all the way down, if you like. And in the back, you can go like this. So this is actually the upper part of the sphere. All right, so who is this? The top here is that sphere. So the top one here is z equal square root of 16 minus x squared minus y squared. So we know that the volume is equal to the double integration. Who goes inside z, which is the square root of 16. Look at this one. This can be written as minus x squared plus y squared, which is what? R squared, and then r dr d theta. You know why? Because this can be written as 16 minus out x squared plus y squared. And this is r squared, so this is going to be 16 minus r squared. Now look at the base. What else do we have, guys? You have a circle of radius 1. So let me make a circle of radius 1 with different color. Here's the red. Circle of radius 1, here it is, guys. But this is what? We're not having a circle. So we need what? A cylinder. So because here Z is a free. So let me erase these two guys. And let's go up with this circle. So it's going to go all the way up. So we have what? We have a cylinder that goes up. And this will create here the top sphere. This is now is going to be the top. But there is another one, which is what? X squared plus y squared equal to 9, which is a circle of radius 3. Here is a 3. Here is negative 3. So we will make another one. A circle of radius 3. And in the back, a circle of radius 3. So this is going to go up here. And it's going to go up here. So what do we have? In the back, we have this. So now we need to find the volumes, okay, bounded by, on the top, bounded by this. So actually, if you look carefully at the whole graph, it will look like this. So I'm going to change the color to show you what's the final result, guys. The final result is actually everything between this circle and the small circle. So it's, you see, to graph it, so it's going to be like this. That part, you see? And this is our, it's everything in between. So this is our surface on the top. See that? It's between them. So I need this surface. Okay. And it goes all the way down. Here it is. And from here we go down. And this is our base. See the volume now? It's everything. So this inside here is empty. This here is empty air. There is nothing here. It's like a hole. And it goes all the way up. Now, who's that top thing? That top thing here, that top thing is our function z equal and goes inside. Now, where's the base, guys? Look at the base here. I'm going to make the graph on the XY plane. What do I have in the base? I have two circles. One of them is of radius 3. And the second one is of radius 1, right? Here is 1 and here is a 3. And it's everything in between is my region. The region and base is everything in between. This is our region. It's everything in between. So what do we do now? We take actually a R. R is gonna be here, guys. This is our R. Usually it starts from here, okay? But okay, let's see. What is this distance from here to here? From here to here. What's this distance? It's all this distance, which is what? 3, right? So I'm going to say for R, it's not going to start from 3. It's going to start from where? From 1, 2, 3. So this is the length, right? Always R is the beginning and the end. The beginning is at 1 and the end is at 3. So this is the length of that ray. Now what's going to happen for this ray? It's going to keep on moving up to cover the whole thing. How much do we rotate? You can tell this is full rotation. So theta is from 0 to 2 pi. That's it, guys. This is how you do it. Now, to integrate this one faster for you guys, we did this one a minute ago. Here it is. If you look at that one, this worked. Where was that thing here? Okay, let u equal to that. So this is equal. So this is what you get actually. The final result is going to be always like this. It's minus 1/3, 4 minus, because here you have 4. There we have 16. So it's going to be 16 minus r squared to the 3/2 over 3 with negative. So this is equal to the integration from 0 to 2 pi. Then we're going to write the result of the integration is 16 minus r squared to the 3/2 over 3 with the negative. Okay, let me go back and see. This is what we got. All right, so we have, and yep, this is exactly what you get. So let's use it. Why do we have to do it again? It's already been used. And this is from 1 to 3. And then d theta. By the way, yeah, 1 to 3. So now what do? We plug the 3. So this is equal to the integration 0 to 2 pi of, put the 3 first, you get minus 16 minus 9 to the 3/2 over 3. Minus with minus becomes plus. We put the 1, 16 minus 1 to the 3/2 over 3, and then d theta. 16 minus 9 is 7. So this is equal to the integration from 0 to 2 pi of negative 7 to the 3/2 over 3 plus 15 to the 3/2 over 3 d theta. Take these two guys outside. So I'm going to start with 15 to the 3/2 over 3 minus 7 to the 3/2 over 3. All of this goes out. And I'm left with the integration from 0 to 2 pi of d theta. We already did this one. The answer of this one is 2 pi. So the final answer is 2 pi. Then 15 to the 3/2 over 3 minus 7 to the 3/2 over 3. And we close. That's the final answer. All right, let's evaluate this integral. You have x squared minus y squared, then dy dx. And this is 9 minus x squared. So here's an error. This is plus x squared plus y squared, then y dy. I need to integrate this one. Of course, this cannot be integrated in any way because the derivative, if you want to integrate with respect to y, you need the derivative inside, which is d2y, which does not exist. If you switch, you need the derivative of x squared, which is 2x, which does not exist. So this is not integrable. So what do we do in this case, guys? We will actually convert everything to polar. So what do we have, y? X is from where? -3 to 3. So I'm going to copy here. X is from -3 all the way to x equal 3. Y is from 0 to y equal 9 minus x squared. So let's graph this one, guys, here in the xy plane, not in 3-dimensional, but 2-dimensional. Why? Because I'm talking about the region only. X is from -3 to 3. and y is from 0. By the way, y equals 0 is the x-axis, right? So this is y equal to 0, up to y equal this. What is this? This is the upper half of a circle of radius 3, isn't it? So this one actually is y equal 9 minus x squared, because this is a circle of radius 3, and this is the upper half of a circle of radius 3, and we showed this one in the previous examples. If you remember, you can say this is y squared is equal 9 minus x squared. Bring this one here, so x squared plus y squared equal 9, and this is a circle of radius 3, but since there is a positive square root, so it's only the upper half. That's it, guys. So you're done. So what do you say the answer is? So the answer is double integration of the square root. We know that x squared plus y squared is what? Is r squared. And what do we say? R dr d theta. Now, look at this circle. What do you need? Look at r. Here is r, guys. Where does it start with? Starts from 0 to 3. So r is starting from 0, ends at 3. To cover the whole circle, how much does r rotate? Half rotation, so from 0 to pi. That's it, and you integrate that one. This one, by the way, is r, so this is equal. We start from the inside. So this is the integration from 0 to 2 pi. Then the integration from 0 to 3. This is r, and r is what? R squared dr, then d theta. Again, we are inside. What is this equal to? Integration from 0 to 2 pi. What's the integration of r squared? It's r cubed over 3 from 0 to 3, then d theta. And this is the integration from 0 to 2 pi. Put the 3 here. What do you get? You get 3 cubed, which is 27. 27 divided by 3 is 9. So you have 9. Put the 0, you get 0. It's gone. Then what? D theta. Take the 9 out. 0 to 2 pi d theta. We already know that this is 2 pi. So the answer is 18 pi. This is exactly the result of the integration. Let's look at this one. All right, so we have this thing. All right, let's look at one by one, by the way. Let's look at the first one, guys, here. What do you see on in this one? X is from 0 to 1, so maybe we can graph it. Here is x equals 0, and here is 1. And then y is 1 minus x squared up to y equal 4 minus x squared. This is a circle of radius 1, isn't it? But which part of it? The upper part. And this one is a circle of radius 2, but the upper part. So y is from here to here, guys. It's this upper circle. But x is only from 0 to 1. So where is my region? Look at this. X from 0. This one is x equals 0. And this one, x equal 1, isn't it? And then from y, this is y equal 1 minus x squared. And this is y equal what? 4 minus x squared. So this is our region. This is our first region, by the way. If you look at the second integral now, x is from what? From 1 to 2. From 1 to 2. Beautiful. So we are here. And y is from 0. Where is y equals 0? This is y equals 0, isn't it? To y equal what? The upper half of the circle. So here it is. So here is x equal 1, guys. Here is x equal to 2. From 1 to 2. And then from y equals 0 to y equal to this. So this is the second region. So what's the final region, guys? It's everything you see here. This is our sum. Both of them will give me this, huh? All right. So what can I say? So this is equal to the integration. What I'm going to do now, I'm going to take R, change the color. Here is my R, guys. R starts from where? So I'm going to say, both of them are, by the way, you're going to join them in one piece. So on the top, what do you have? You have x squared. What's x squared? You know, an x equal R cosine theta. So the top is R squared cosine square theta over. What's the bottom? It's x squared plus 1 is what? Is R squared. So this is over R squared. And then we say R dr d theta. I don't have to have both. One is good because both of them represent this. And then R is from where? From 1 to 2. So this R is from 1 to 2. But to cover the whole region, we're going to continue all the way what? Up to, we're going to stop here, isn't it? And this, what's the angle here? It's pi over 2. So the angle is from 0 to pi over 2. And this is what both integrals represent in our work, guys. So what do we have? R squared goes with this R squared. And we start the integration from inside. So what is this equal to? Integration from 0 to 2 pi. See, cosine square has nothing to do, so I'm going to take it outside. And integrate from 1 to 2 of what's left is R dr only. Okay, so I took the cosine out and I'm going to deal with theta. Why did I take the cosine theta out? Because I'm integrating with respect to R. So it's constant. You can kick it out. And this is equal to the integration from 0 to 2 pi. Cosine square theta. Now, what's the integration of R? It's R squared over 2 from 1 to 2 d theta. And this is 0 to 2 pi. Cosine square theta. Now let's see what it is. Put the 2, you get 4 over 2, which is 2, minus, put the 1, you get half d theta. This is a 3/2 goes out. So what am I left this? 0 to 2 pi of the integration of cosine square theta d theta. Now we are in another dilemma, is how do we integrate cosine square? What's the integration of cosine square? You know, there's a formula for this one, which is 1 minus cosine 2 theta over 2 d theta. And this is equal to the integration of half d theta minus the integration of half out cosine 2 theta d theta. And this is equal to half theta minus half. Now look at this one, guys. To integrate cosine 2 theta, what do I need? I need the derivative of the angle. What's the derivative of 2 theta? It's 2. There is no 2 here, so I'm going to multiply inside by 2 and outside by half. Half times half is 1/4, so the answer is going to be here 1/4. Then what's the integration of cosine? It's sine 2 theta. All right. And you can go back to our previous chapters in my course, the other course of Calculus 2, you will get this integral. So this is the result of this one. So I needed 2 inside here. I don't have it. I multiply inside by 2 and outside by half. Half times half is 1/4. Now the integration of cosine theta, since the derivative of the angle is there, the integration of cosine theta is sine 2 theta. So this is equal to 3/2 open bracket theta over 2 minus sine 2 theta over 4, and this is from 0 to 2 pi, guys. And this is equal to 3 over 2. Plug 2 pi here. So what do we have? We have 2 pi over 2 minus sine. If I put 2 pi here, we get 4 pi over 4. Minus, put the 0, you get 0 over 2 minus sine 0 over 2. Sine 0 is 0. This is 0. Sine 4 pi is also 0, by the way. This 2 goes with this 2. So what am I left with? The final answer, 3 pi over 2. This is the result of the integral. Let's do that one. How would you integrate this one? So let's look at this one. This is a region of type 1, of course. X is from -5 to 5. Here is -5, and here is 5. X is only from -5 to 5. How about y? It's from y equal to 0. And by the way, this is y equal to 0. To y equal to what? This is a circle of radius 5. Here it is. And it's only the upper half, right? So this is y equal 25 minus x squared. It's the upper half of the circle, as we all now know. All right, so what do we say now? So this is equal to the double integration. Take any ray here inside. This is our r. Okay, what do we say? Let's keep those for a while. We replace dy dx with what? R dr d theta. Now r is from where to where? The beginning is 0, the end is 5. So from 0 to 5. Now to cover all this half circle, how much do we travel? From 0 up to what? To pi. So the angle is from 0 to pi because this is a half circle. So this radius, this circle, if I take a radius from 0 to 5, rotate it, it will cover all this half circle. Now, times 4. What do we know about x? We know that x is equal r cosine theta. And r here is what? 5. So it's equal to 5 cosine theta. So this is 4 times 5 cosine theta plus 3 times, we know that y is equal r sine theta, and r is 5, so this is 5 sine theta. So this is 5 sine theta. And we close. And this is equal to the integration from 0 to pi, integration from 0 to 5 of 20 cosine theta plus 15 sine theta, all r dr d theta. We said, what do we start with? We start with the inside. I'm going to integrate with respect to what? To r. So the best way to see it is to kick anything that doesn't have r outside. You see, those are theta, so we can kick them out. So 20 cosine theta plus 15 sine theta can easily go out, and we integrate from 0 to 5 of r dr, and then all of this d theta. And this is equal to integration from 0 to 2 pi of 20 cosine theta plus 15 sine theta. Now, what's the integration of r? It's r squared over 2 from 0 to 5. Then d theta. But here, if you put the 5, you get 25 over 2 minus 0. So 25 over 2 goes out. So this is equal to 25 over 2. And then what do we have? We have the integration from 0 to 2 pi of 20 cosine theta plus 15 sine theta d theta, which is equal to 25 over 2. Now, what's the integration of cosine? It's sine. So this is 20 sine theta. What's the integration of sine? Negative sine. So minus 15 cos theta from 0 to 2 pi. All right. So this is 25 over 2. Put 2 pi. So this is 20 sine 2 pi minus 15 cosine 2 pi. Then we say minus 20 sine 0 plus 15 cosine 0. You know, we change the sign because the bottom one, you say minus. Minus this, minus becomes plus 15. Now we know this is 0, sine 2 pi is 0, and sine 0 is 0. This is 1, and this is 1. Minus 15 plus 15, they cancel, right? So this one goes with that one. And the final answer is a 0. So this is how you evaluate the integral. This is, guys, the end of all those questions. So 8 questions about polar coordinates. I hope you enjoyed it. It's all RD theta. The base has to be something circular with a radius, something has a length from A to B, whatever the length is. And then the rotation is from a certain angle to certain angle. And that's all what we do in the polar coordinates. Now we see you in 9:12 in a minute.